Bioclimatic house project. In a context where sustainable construction is becoming a priority, the choice of a bioclimatic house is an innovative and responsible response to environmental challenges. This project proposes the construction of a house integrating a vegetated earth cover, designed using 3D modeling by Rhino software. This approach combines aesthetics, energy performance, and resilience to external elements. The project is the result of an idea by Francis Pratt. As can be seen in this photo, a hut with a green roof disappears into its surroundings. In this case, the topsoil covering the roof is only 2 inches thick. It has been planted with sedums that can withstand drought in summer. The other plant species have grown naturally. There is no automatic or manual watering. Pursuing the same idea, a bioclimatic house stands out for its harmonious location in the landscape. It promotes natural orientations to optimize solar gain in winter and protect against summer overheating. The CAD design makes it possible to visualize and adjust every architectural detail, from the main volumes to the strategic openings for natural ventilation. Built in a desert region, the bioclimatic house will be covered with earth, rocks, and cacti. Built in the Mediterranean regions, it will be covered with Gora and Lipia yarrow. Built in Northern Europe, it will be covered with ferns and mulberry trees. The owner will therefore be able to customize it as he wishes. The concrete walls that surround the openings can be covered with climbing plants. The roof and part of the walls are covered with a thick layer of vegetated soil, cultivated with local species and not requiring much maintenance. This plant envelope acts as a natural barrier against thermal variations and provides multiple benefits. The earth stores nighttime coolness and slows the penetration of daytime heat, ensuring stable indoor comfort during heat waves. Thermal inertia of the vegetated substrate delays the cooling of the house, limiting the need for heating during the winter. In the event of a forest fire or external fire, the earth creates a non-flammable buffer zone that protects the concrete structure. If the house is built on a cellar, the excavated earth will be used to cover the house. This will limit truck transport with the resulting pollution and costs. Let's see now the house without earth on top. The water-repellent concrete is coated with a flexible waterproofing. The 3 beams that support the ceiling of the house have a maximum height of 1 meter for a span of 10 meters. The external dimensions of the house are 20 by 10 meters. The concrete walls that frame the windows move away from the facade to improve the field of vision that the inhabitants have from the inside and to make it easier for light to enter. The slope that allows access to the roof is 45 degrees. It will therefore be possible to climb it easily to maintain the vegetation. Some may draw a winding path at the corner of the house. A roller shutter box can be installed above each opening. If the shutter is made of steel, it will effectively protect the house against forest fires and intrusions. It will be hidden by the earth covering the awning. The volume of earth on the roof will be approximately 120 cubic meters, or 180 metric tons. The construction could be carried out with panels to pour concrete, but it could also be done with a 3D printer that deposits successive layers of concrete to make the walls. The ceiling height is 2.7 meters. The thickness of the slab is 1 foot. The plan of the house is planned with 1 foot thick walls made of concrete on the outside and polyurethane or polystyrene on the inside with a plasterboard finish. Considering the 2 layers of isolation of the house, it should be possible, in temperate regions, to avoid heating or air conditioning. The bioclimatic design and the vegetated earth cover offer benefits beyond simple thermal or fire protection. Creation of a habitat for local fauna and flora thanks to the living roof. Plants filter dust and pollutants, contribute to a healthier environment. Gentle integration into the landscape promotes social acceptance of the project. Rainwater collection for a few minutes at each shower limits runoff that could lead to the overflow of nearby streams or rivers. Given the exterior structure that eliminates posts, homeowners can easily play around with the layout of the partitions to tailor the plan to their needs. After talking about it with my relatives, they find that the house looks like a blockhouse. So I replaced the concrete walls with half columns of 1.5 meter in diameter which are filled with earth to obtain a thermal inertia comparable to the initial formula. These columns support a 1 meter projection covered with earth which improves the thermal inertia of the building. The conclusion is that this bioclimatic house covered with green earth embodies a contemporary vision of housing, which is both efficient, protective, and in harmony with nature. This project illustrates the synergy between design technology and ecological principles to build tomorrow, today.